Okay, here's 3 questions involving trig. First question says, vehicle is going 100 kilometers an hour. Diameter of the wheel, radius of the wheel is 12.5 centimeters. What is the angular velocity of the wheel? So that's the W. So I know my formula V is equal to RW. So to solve for W, I'll divide both sides by R. So W is equal to V divided by R. Okay, velocity is 100 kilometers per hour. The radius is 12.5 centimeters. Okay, I got to get the centimeters and kilometers together. So I know there's 100,000 centimeters in 1 kilometer. Notice I put the centimeters on the top, so those would cancel. These would cancel also. And so my answer here, units, there's none, but I'm looking for angular velocity. So it'll be in radians per hour. What do they ask for? Oh, they want it in pi radians per hour. Oh, interesting. And revolutions per hour. Why would they want it in pi radians per hour? Anyway, radians per hour, and we'll do revolutions per hour. So there, what I have, I think, is ready to go. So let's try that with the calculator. So 100 times 100,000 divided by 12.5. So that looks to be 800,000 radians per hour. That's a whole lot of radians. But I know that each radian is, or 2 pi radians is 1 revolution. So if I have 800,000 radians per hour, I can multiply by 2 pi radians are the same as 1 revolution. So the radians cancel. Now I can just divide that by 2 pi. So it gives me something like 127,389 revolutions about. So that's how many times the tire would go around. That is revolutions per hour in 1 hour. Okay, so that's that question. Next question. Wind turbine, radius of 40. A windy day, the turbine takes 5 seconds to go around. What's the speed on the tip of the turbine? Okay, same formula. V is equal to R. We know what the angular velocity is because it's 5 seconds to go around once. So I can figure out a speed. So the velocity is equal to the radius is 40 meters times angular velocity is I go 2 pi radians in 5 seconds. Now they don't specify what speed they want. I guess we'll just write whatever speed we want. So if I go 2 times pi times 40 divided by 5, so that's going to give me 50.265 meters per second, which is, I guess, fairly fast, but I'm not sure how fast that is in my mind. I think in kilometers per hour. Let's convert it to kilometers per hour. I know there's 1,000 meters in 1 kilometer. Meters cancel. And seconds, I know there's 3,600 seconds in 1 hour. Seconds cancel. So my units that I'll have is kilometers per hour. So I take that number I have and times it by 3,600. It's a huge number. And divide that by 1,000. Okay, so it gives me, let's round it, so 181 kilometers per hour. You'd be going fairly quick on the tip of that turbine. Okay, this next question asks you to find the equation of a sine curve that fits the data. Graph the data on your graphing calculator or decimals. take a picture. Okay, we did that when we were doing it online, but you'll have to sort of sketch one for me. But let's do this with Desmos. So let me get my Desmos going. And so Desmos, here we go. Okay, so first thing I'd want to do is to get my table data in. There we go. So let's add a table. Okay, we'll add all these numbers. That's a lot of numbers to add. So it's going to take me a second. Let me pause and then I'll press play when I'm done. Okay, I've entered all the data. And now I want to come up with a graph that describes that data. Okay, so let me come down here and I want to add another function. So I want y1 and not equal, I have to use that tilde thing. And I want it to define a, and then sine, b, and then x1 minus c plus d. There. So we want it to define that data, come up with a curve with that. Okay, let me make this just a little bit bigger. Okay. All right, so there's my A value, my B value, my C value, my D value. But I can't see my graph. Where's my graph? Oh, here it is. There it is. There's my data. Oh, that's some nice looking data right there. Boy, and that curve did quite a good job. Okay, so if I want to then write out the function for that data that I've got, I would write, go in red. So y is equal to a is 51 point, let's go to 2 decimal places, 51.35 sine bracket b is 0.20 bracket x minus, oh, it has two minuses there. I'll put them both in. So minus a negative 8.20, okay, plus 49.98. I think that's good. Those two minuses would cancel to a plus. So there's my function that describes that data. So if they want to know what the amplitude is, it's the absolute value of A. So it's just going to be 51.35. If they ask me for the period of the graph, it'd be 2 pi divided by whatever b is. So 2 pi divided by b is 0.2. So what's that come out to? 10? 10 pi? I don't know. 10 pi? 31.4, something like that. Yeah, that'd be about right. Because if you start here, up here, and you end there, it's doing that in about 30. Yeah. So 10 pi or 31.4, somewhere like that would be good. If they ask for the phase shift, you can just tell them that it's this number right there. So the graph has been shifted to the left by 8.2 units, and then vertical translation is just whatever that number is, 49.975 or 98 up. All right, hopefully that helps you with those three questions.